Imagine you are looking for a topic in a textbook. You would look at the index. Now imagine that this index was not in order. It would be very difficult to find things. Indexes are usually sorted alphabetically, from A to Z. This means all the A's are at the start of the index. This way it is easy to find what you're looking for. In computing, we often need to sort a list of data. One of the things we might want to do is sort a list or array of data. We might want to sort it numerically from high to low or from low to high. Here we have a list of numbers and we have sorted them from high to low. One of the ways we can take an unsorted list of data and turn it into a sorted list is by using a sorting algorithm. One of the simplest sorting algorithms is the bubble sort algorithm. Consider three numbers in an array at indexes 0, 1 and 2. The bubble sort algorithm will work as follows. Compare the first two numbers at index 0 and 1. If one is bigger than the other, they are swapped. Then the numbers at index 1 and 2 are compared. If one is bigger than the other, they are swapped. This is repeated for all numbers in the list until all numbers are sorted. It is a very simple algorithm to code, but as the size of the data increases, you need to do lots of passes where you need to repeat the algorithm on the list. This means it becomes very slow. Depending on whether you want to sort your data in ascending or descending order, this will affect when you will swap each piece of data. For example, if you want to sort numbers low to high, you'll only swap if the current data item in the list is larger than the next data item. The pseudocode for this algorithm looks like this. As you can see in our code example, we have two loops. The first loop, which we will call our outer loop, says this. This will make us loop through our array repeatedly until everything is sorted. The second loop, which we will call our inner loop, says this. This loops through the length of our array. The size -2 means we won't try and swap the final array element with a non-existent element after it. However, the most important part of this code is this bit. Let's look at this line by line. The data we're sorting is illustrated in this table. In the first line of this code, we're checking if the data at position 0, which is 9, is greater than the data at position 1, which is 7. This if statement is true because 9 is greater than 7, so we execute the rest of the code inside this if statement. Inside the if statement, we take the data at position 0, which is 9, and store it in the new variable called temp. This is short for temporary, as we're using it to temporarily hold the value while we swap it. Now we take the data at position 1, which is 7, and store it in the array at position 0. Next, we take the data we stored in our temp variable and store it in the array at position 1. The final line of code simply sets the sort flag variable to false. This ensures that once we've finished our current loop through the array, we'll make another pass to check whether everything is sorted. We can then simply keep repeating through this until everything is sorted. We've seen the code for a bubble sort algorithm and in theory how it works, but what are the stages it goes through in order to fully sort an item in a list? The following sequence of tables shows how this bubble sort might work. Consider three numbers in a list as shown. The list is unsorted as we want to sort it low to high. When we enter our inner for loop, we start our first pass through our list of data. We first check if data 0 is greater than data 1. It is, as 9 is greater than 8, so these values are swapped. Next, we check if data 1 is greater than data 2. It is, as 9 is greater than 7, so these values are swapped. Now we have looped through our array once, so our inner for loop is complete. However, our data is not sorted yet. This is why we have our while sort flag equals false loop. When we swap down numbers around, we set the sort flag to false so our algorithm knows we need to loop through the array again. So now we enter our for loop again and start our second pass through the array. We will first check if data 0 is greater than data 1. It is, as 8 is greater than 7, so these values are swapped. Next, we check if data 1 is greater than data 2. It isn't, as 8 is not greater than 9, so these values are left where they are. We've now looped through our array again, so our inner for loop is complete. You can see our data is now sorted in order. An important thing to note here is that while our data is sorted, the bubble sort will always perform a final pass of the loop. This is one of the reasons why it is inefficient. So, sorting is where you put a list of data items into some form of order. One of the ways of doing this is called a bubble sort. It works by looping through a list of items and swapping two items next to each other if one is higher. You have to keep looping until you reach the end of the list. You then have to start again until each item is sorted. You can sort low to high or high to low. It is not a very efficient algorithm as you have to carry out an extra loop even after the information is put in the correct order. It is only used for small sets of data or data that is already mostly sorted.